So I think the assignment 5 I have not discussed so far. So what I thought in this thing in this week course is that I will just discuss the solution for the assignment 5. So did you submit the assignment 5 solution, by the way, Asutosh? Okay, okay. So okay, so like if possible, you try to speak sometime. Okay, then it will be easy to uh, like for me also to talk. So I'll just the first few questions are very simple. Okay, are you able to see my screen, by the way, where I am showing the questions right now? Okay, okay. So the very first question is easy. Okay, so the first question says that the position vector of a particle is given by a function of time, where that r is the position vector. Sorry, it is c1 plus c2t plus c3t cube I cap, so that I hat is the direction along x, and plus c4t into j hat, where j hat is the direction along y, uh, where the value of c1, c2, c3, c4 everything is given, and you need to calculate that what is the acceleration of the particle at time t equal to 2 seconds. So it's a very simple problem. Just you need to like differentiate that r expression with respect to time twice. That's all, right? So let me go through the solution now. Okay, are you able to see the solution screen, everyone, where I am showing the solution? Hello? Hello? Okay, okay. So so that r has these expressions. So one way you can write that x is equals to this first part, and y is equals to first part, and then you can differentiate twice with respect to t differently for x and the y. But here you can do at the same time that v is equals to dr dt. So you just differentiate it first, so that differentiation of that constant c1 is 0. It will be c2 plus 3 c3 t square I cap plus c4. Now the acceleration is the second derivative of the positions. So sorry, yeah, second derivative of the positions and the first derivative of the velocity. So it should be 6 c3 t into I cap. And what is the value of c3? c3 is given as the value of c3 is equal to 3 and t is equal to 2 seconds. So if you now substitute all of that here, it is 36 meter per second square. So it's a very simple and straightforward question. There is nothing like new in this. Now let me go to the next question. So the next question says okay, so the next question says that at any instant the horizontal position of the weather balloon in figure 1 is defined by x equals to 2t. So you have, so if you see the picture, you have a weather station and you are just launching some balloon, okay, weather balloon, like with a GPS inside, which will measure the temperature, mostly the temperature, with the height, okay, and that balloon is following this path. If you draw that path in xy plane, it shows that xy is equals to x square by 10, okay. So it's a parabola, okay. I mean the y equal yeah, like y equal to ax square. Then so we know that how x is changing, because that is given, that x is equals to 2 into t. Now we know that how y is changing with respect to x, that is y is equals to x square by 10. We have to find the magnitude of acceleration of the balloon again at the t is equals to 2 seconds, okay. That is how we have been asked. Now let me see, like again here also it's very simple. So x is given, that means the derivative of the position x with respect to time twice will give me the acceleration, along x direction. So my x is equals to 2t, that means ax equals to the second derivative of t with respect to time, which is 0. Now the interesting part is that I have also given the trajectory of that balloon, that means y is equals to x square by 10 is also given, okay. So if it's y is equals to x square by 10, now again the x is given at now x is also known as a function of time, okay. So that x is equals to 2t, that means it should be 4t square by 5, okay. Sorry, it should be 4t square by 10, that means it is 2t square by 5. So now I know y also as a function of t. So x I know as a function of t, I know y is also a function of t. So if I do the derivative of this quantity twice, again ay is equals to this. So derivative of that y is equals to 2t square by 5 twice, if I do, it turns out that it is 4 by 5. That means the magnitude of acceleration of that balloon at time t is equals to 2 is equals to root of ax square plus ay square equals to 0.8. So that means its acceleration is constant, it is independent of time. So if you launch a balloon from a weather station, like in this case, if it's follow a parabolic trajectory from the ground, its accelerations will always be constant, okay, because we have not used the data that t is equals to 2 seconds. At all the time its acceleration is 0.8 meter per second square, okay. So that is what we are getting from the. So the first two questions is very simple, it's only like you have to use the simple formula, nothing else, that the velocity is the rate of change of displacement, acceleration is the rate of change of velocity, just that like the derivative of that, okay. That means v is equals to dx, v is equals to dr dt, and a is equals to dv dt, and those derivatives are valid for the like for each of the components also. If you write that r in terms of a vector, that xi plus yj plus zk, then v you can write as dx dt I cap plus dy dt j cap plus dz dt k cap, and similarly the acceleration. That is what the main two message here, okay. There is no complicated motions involved, it's just simple derivatives, the first two questions, okay. So it's and like in your end sem also, I think one questions will be related to this only, like where you need to do only the derivatives, that's all, okay. Great. So again the other thing which I like wanted to say here is that this acceleration here, it is dv dt, okay. Now you can write it as a dv dx into dx dt. Okay, this acceleration, and dx dt or the dr dt is again v, that means v dv dt. So that means this, sorry, v dv dx or dv dr you can write in that sense. So like in case of a 1D, I mean the unidirectional motion, you can write that ax is equals to vx into dvx dx, ay is equals to vy into dvy dy. So those things are also sometimes important, and again here we have provided the expression for position, and we have been asked to calculate the velocity and acceleration and all. In the other way also it is possible, if it is given that this is the acceleration, what is the position at some time and what is the position when the velocity is this, you need to do the integration of this quantity with respect to time. That's the only difference. Okay, and sometime in few problems using the other form, that means acceleration equals to v dv dx. Okay, that is also sometimes important, because in that case you can omit, you don't need to deal with the time, you have to deal only with the positions and the velocity. Okay, that's the advantage. So if the time is not given, you can only like deal with the position and the velocity and you can do the job. Okay, so it's not a big thing. Now all of these are in Cartesian coordinate system. So that Cartesian coordinate system means it's only x, y and z, where x cross y is equals to z. That is the simple coordinate convention in case of a Cartesian coordinate system. That means I cross j is equals to k, if I say in like the vectorial, in the unit vector form. So but there are other coordinate system, and the other two well-known coordinate systems are again the cylindrical, like the cylindrical coordinate system. In 2D it's cylindrical polar coordinate system, where it is r and theta, and in 3D it is r theta and z. Okay, where the r is again from the origin, the distance of that point in that space from the origin of the coordinate system. Okay, theta is that if you project that line on the xy plane, and if you like measure the angle with the x axis, that is theta, and z is the distance from that xy plane to that point. Okay, the perpendicular distance, like if you project that point from there up to the xy plane, like the distance which will you get is the z. And similar way you have the r theta phi in the spherical coordinate system. Okay, even though I will not go into the spherical coordinate system, and also there are other coordinate system. Okay, elliptic coordinate system, like there are many other coordinate system which is not like required for this course at all. So let's solve other problem which involve the spherical coordinate system. So what is the relation between the spherical in the cylindrical and the Cartesian? That in cylindrical it is r, okay, r theta and z, and in Cartesian it is x, y, z. So you can easily say that x is equals to r cos theta, y is equals to r sin theta, and z is the z, same z. Okay, so you can always relate that, like if I have the coordinate value in cylindrical coordinate system, what is the same coordinate value in Cartesian coordinate system, that you can easily do the conversion. Okay, it's not a big task. So let's see what's the next problem says. So in the next problem it says that, like, let me go through the questions once. Yeah, so a jet plane flying at a constant speed v at an altitude h is equals to 10 kilometer is being tracked by radar. Like this is typically how they track any airplane. Okay, is being tracked by radar located at O. from a station, okay, from the like station from where they track the plane, they are just measuring it, that is located at O, directly below the line of flight. Okay, so that means it's just a completely simplified problem. Okay, in reality that station might not be exactly below that station, so in that's how they are just neglecting the z coordinate in this case. Anyway, so that h is given, which is 10 kilometer. If angle theta is decreasing at a rate of 0.020 radian per second, then magnitude of the velocity v of the plane in kilometer per hour when that theta with the horizontal of that line from the plane to the station, that angle is given as 60 degree. So when that angle is given, my height is given, and also I am given that how that angle is changing, so with respect to time. That means in mathematical sense it is theta dot is equals to d theta dt is equals to minus 0.020 radian per second, and h is given, and also that theta is given. So what I first need to do now, let me go to the solution and it will be easy to explain. So first I need to write that. Now look at the schematic here in this figure, okay, for the question 3. So this is my theta and this is my r, this is x and this is y or h. That y is fixed in this case because the plane is moving at a like horizontally. There is no vertical thing like the vertical motion which is given here in this case. Okay, so I need to calculate the velocity v, which is completely along the x direction. Okay, I mean the velocity is completely horizontal in this case. So if the velocity is horizontal, then x dot is equals to dx dt will give me the horizontal velocity. Are you agree with that? Because there is no y dot. I mean the y is the fixed height. Okay, so there is no y dot, so only x dot is given. Now this is my r and this is theta. So what is x? X is equals to r cos theta and y is equals to r sin theta, but y is fixed in this case. R sin theta is fixed. Okay, because the r and theta is changing in some in a way that the r sin theta is fixed, but x equals to r cos theta, that is changing. Now make a derivative of that with respect to time. So x is equals to r cos theta, x dot is equals to r dot cos theta minus r theta dot sin theta. Okay, because the cos theta is minus sin theta, the derivative, where r dot equals to dr dt, theta dot is equals to d theta dt. Okay, that means how r is changing with respect to time and theta is changing with respect to time. Now this again this r is also x square plus h square. That means r square equals to x square plus y square. Here instead of y it is h. Okay, now you again do a derivative with respect to time of this expression. H is fixed, so that h is not change, that height is not changing with the time. That means the dh dt is equals to 0. Okay, and the second term is 2x x dot. Fine. So if it is 2x x dot is equals to 2r r dot, the time derivative of that term. That means I am just differentiating this term with respect to time, and then from here what I am getting, that r dot is equals to x dot by r. And again, what is the value of x by r? X by r is cos theta. From this expression, x by r is cos theta. Fine. So now if I put here, that means x by r is cos theta, and then I have x dot. That means r dot is equals to x dot cos theta. That is what which I am getting in this case, because the y dot is 0, that's why it is possible. Now I will put that r dot value here. Okay, what I need to calculate, by the way, r dot, I need to calculate that what is the velocity. Sorry, I need to calculate what is x dot. Okay, the horizontal velocity, which is this expression. So r dot is given x dot by r into cos theta minus r theta dot sin theta. So it is, if I take the x dot common from this expression, if I take the x dot common from both sides, it will be x dot into 1 minus x by r into cos theta is equals to minus r theta dot sin theta. Now again x by r is equals to cos theta, okay, and r is equals to h by sin theta. Okay, so if we do that r is equals to h by sin theta, because again y is equals to r sin theta. So instead of y, it is h in this case. Now if you put all of that here in that expression, that r is equals to h by sin theta, x by r is equals to cos theta. So it is x dot into 1 minus cos square theta is equals to h theta dot by sin theta into sin theta. That means it is minus h theta dot, x dot is equals to minus h theta dot divided by 1 minus cos square theta. Okay, what is the value of h? 10 kilometer. Okay, so it's 10 into 10 cube meter, that is my h. Theta is given, that at the instant when theta is equals to 60 degree, what is the value? That is what they are asking. And theta dot is equals to minus, theta dot is equals to d theta dt is equals to minus 0.020 radian per second. Okay, up to that, is that clear? Now you put all of those data here, you will get that what is the horizontal velocity of the plane. It is 960 kilometer per hour. So this is a simple conversion problem where you can easily convert between the Cartesian and the cylindrical polar coordinate system, and depending on that what data is given to you, you can use those data and calculate the quantity which you need to find. Okay, up to that, is this clear? If you have any queries regarding this, so again the similar thing is valid for the spherical coordinate system also. So in the spherical coordinate system, x, y and z are a little different. So in spherical coordinate system, what is the x? So it's r theta phi, right? It is r theta phi. So x will be r cos theta sin phi, sorry, r cos theta cos phi. X will be equal to x will be is equals to r sin theta cos phi, y will be equal to r sin theta sin phi, and z will be is equals to r cos theta. Those are the expressions in spherical coordinate system. Okay, so if those are the expressions in spherical coordinate system, you can easily. So now do you have any questions regarding the conversion between the spherical and the Cartesian, like what I told just now? So in Cartesian it is x, y, z. In spherical it should be r theta and phi. Okay, so what is the relation between r theta phi and x, y, z? So it's x is equal to r sin theta cos phi, y is equals to r sin theta sin phi, and z is equals to r cos theta. Okay, so now I'll go to the so it is so far only the derivatives, nothing else. You need to just apply the trick that from which coordinate system to which coordinate system you have to operate. Sometime if it is like the simple Cartesian coordinate system, it's fine. So those who joined late, for them again I will just say that, like in the assignment 5, the first two problems are only regarding the derivatives. If you see the solution of the first two problems, where you have the position vector is given, you need to calculate the velocity and the acceleration, and you can just do the derivative twice of the position vector with respect to time, and you can get the acceleration. And in the second problem it's the same way, but here only the x, how the x coordinate is changing with time, that is given, that x is equals to 2t, and the relation between x and y is given through the path. That means the trajectory is given, that it's a weather balloon which is launching from the station and it's following a parabolic path, y is equals to x square by 10. So in that way you can also convert the x coordinate like the y coordinate into time also, and you can separately calculate that what is the acceleration in x direction and what is the acceleration in y direction, and you can easily calculate the acceleration of the entire thing. Yeah, Ritik, are you asking some question? Please go ahead. Hello. Do any of you have any queries so far? And the third problem is again little tricky, where you need to convert between the Cartesian and the cylindrical polar coordinate system, where you have been asked that what is the horizontal velocity of the flight, given that how theta is changing and how that angle is at that time of at that time, and the height is also given. You just need to express x dot in terms of r theta dot, and yeah, I mean r and theta dot, where r again you can express in terms of h by sine theta, where h is given, theta is also given. So now I will go to the fourth problem. So let me go to the fourth problem. Yeah, this might be little interesting. Yes. So can like any of you tell me how will you approach this problem? So again, one thing I need to clear is that these are the kinematics problem. That means you are interested into the geometry of motion. So what I mean by geometry of motion, that means the trajectory, path, that which path it's following. Okay, what is the position, what is the velocity, what is the acceleration. But we are not discussing about the cause of those change in velocity, position and acceleration. Okay, when we will discuss those cause, that means we will directly go to the Newton's third law or some other method to solving those kind of problems. That is called kinetics, like that. This is kinematics, okay, and that is kinetics. So we'll talk about the kinetics probably later or like in the next week, but these are all perfectly kinematics problem. It's only related it's only relates the velocity, position and the acceleration. There is no, we are not discussing about the forces here. So these are purely the kinematics problem. So let me go through the problem 4. So it's problem 4 says that bar OA. Yeah, you have some questions, Shweta? Go ahead. Oh, okay. So it says that bar OA has a counterclockwise angular velocity omega naught is equals to 2 radian per second. Rod BC slides freely through the pivoted collar attached at OA. Okay, the angular speed omega BC of the rod BC. So that is what you need to calculate, that how that 60 degree is given, right? That theta is equals to 60 degree. This thing is given. Okay, but how that angle is changing, how the angular velocity of that rod BC is changing when you have given that this is the angular velocity of that rod OA, and because of the slider these will also rotate. I mean, there will be also some angular velocity of that rod BC. That is what you need to calculate. Just give me a second. Yeah, so now, so the like as I said at the beginning, that these are the kinematics problem. Okay, so that means you can solve the problems by using the geometry. Okay, nothing else. So let me see that how you can solve the problem. Okay, so this is the schematic, that this is my rod, this is that A is that collar which is sliding along BC, and this is my rod OA, and this is BC. This angle is theta for the sake for the like I'm giving this angle as theta as a notation. This is 250 millimeter it is given, and this I am saying that the R, that means the distance between AB is changing because the point A is sliding along BC, so that distance is changing. That changing distance I am denoting by R, and this beta is the angle between the horizontal beta is the angle between the horizontal and the beta is the angle between the horizontal and this rod BC, which is also changing. Okay, now I have drawn a perpendicular from point A to the OA. Now this OB is fixed because OB is not changing, both of them are fixed, like some joint is here and some joint is here, those are fixed. Only that rod OA and BC can rotate about those joints, but that joints have no velocity, those are fixed. That means OB is fixed. Now this H I can represent in two ways. One is that H is equals to R sine beta, H is equals to R sine beta, and H is equal to this OA sine theta. Am I right? And this OA is given, that is 250 millimeter. Okay, so that means H is equals to 250 millimeter sine theta is equals to R sine beta. That is 250 sine theta is equals to R sine beta, where theta dot is the angular speed of OA, beta dot is the angular speed of BC. I need to calculate what is beta dot, by the way. That is something which I need to answer, that this is my beta dot. So if I do the derivative, like the time derivative of this quantity both side, so it is 250 theta dot cos theta, because the sine theta is cos theta and theta is theta dot, is equals to R beta dot cos beta plus R dot sine beta. Fine. Up to this, is this fine? So this I am saying this is equation number 1. Again from that same equation without the derivative, I can express R in terms of theta and beta, that R is 250 sine theta by sine beta. This is my equation 2. And the another thing which I know, so these are again, I am just using only the geometry, nothing else. That this distance h is fixed. I equated this distance with the two bar lengths. One is r and one is 250 with their corresponding angle with the horizontal. The other thing which I did is that I just take the time derivative of that and then equated them. That is the one constant. And the other thing is that this OB is fixed. And what is OB? OB will be equal to r cos beta plus 250 sin beta plus 250 cos theta. So that distance is equals to OA cos theta plus this distance. This distance is equals to r cos beta. Now again you take the derivative of OB. The distance OB is not changing with time. That means its derivative should be 0. Fine. So if you take the derivative again and take it 0, then from here you can get that r dot is equals to this entire quantity. That r dot is equals to r beta dot sin beta plus 250 theta dot sin theta divided by cos beta. Okay. And this derivative is 0 because the distance OB is not changing with time. That's the only reason. Fine. Now what you need to do, you need to put this r dot and r from equation 3 and 2 to equation 1. So then what is the unknown if you put the expression for r and expression for r dot from equation 2 and 3 into equation 1? What will be the unknown in equation 1? It will be beta dot, because the beta also we know. It is given that it's 60 degree. At that instant it is 60 degree. Theta also we know. Theta is also 60 degree. Fine. So we need to calculate what is beta dot. So if you put 2 and 3 into 1, put 2 and 3 in 1, we get, then you need to just do this algebra. It is nothing. So the only unknown in this case is the beta dot, and that beta dot will give the angular velocity of that rod BC, omega BC, which is coming as, so that beta dot here is coming as minus 0.634. Why it is minus? Can you tell me why it is minus? Because it is given that theta dot is equal to something positive, right? Theta dot, what is the theta dot value? Yeah, theta dot is equals to 2 radian per second. So that means the counterclockwise angular velocity is positive. This is the counterclockwise. So when that bar OA will move in the, rotate in the counterclockwise direction, that bar BC will rotate in the clockwise direction. Okay. So because of these two things, that it will rotate in the clockwise direction, counterclockwise direction, it will rotate in the clockwise direction. So counterclockwise, if the counterclockwise direction, if I assume that it's positive, then the clockwise direction will be negative. So that's why that it is minus. The magnitude of beta, the beta dot is numerically minus because it's in the opposite direction. But we are interested only about the magnitude here. Okay, the angular velocity of the rod BC is 0.634 radian per second. So is it like, do you understand that how using only the geometry I solve the problem? If you have any queries regarding so within this one single problem you have like lot of informations that you need to use the constraints, that what are the constraint into my problem, and just use them. That h is that distance. So first I equated h with the two rod lengths. Out of that, one is the variable r and this is 250 millimeter. with their corresponding angle with the horizontal. Then I take the derivative of that, and also that distance between the point O and point B is fixed, so I use that expressions also, and using the three expressions I calculated beta dot. So do you have any queries so far in this question? So it is the question number 4, right? Am I right? Yeah. So this is the question we are talking about. Now you tell me if you have any queries, anything about this question, as far as I explained the solution. Okay. Asutosh, is this clear for you? And all of you gave the correct answer in the assignment, right? So it's not clear for you, Asutosh? Okay, okay, you have no queries, fine. So now let me go to the problem number 4. Here it is little complicated. It's not the easy as the previous question was. So here what it's showing is that you have two slider A and slider B, which are sliding in the opposite direction along a vertical shaft, and those two sliders are again connected via two rods of length 400 millimeter, and they are pinned at point C. And you have asked, and the question is, what is the magnitude of velocity of point C for the position when these angles are theta? So that means these rod angles, if we put a roller at B, let me go to the questions again. If we put a roller at B, what we should do that case? Okay, if you put a roller at 1 minute, a roller at B, roller as in, like you are saying, it's a not sliding, but it's a pin joint. That's what you are saying, that you hinged at point B. Instead of sliding, you just hinged at point B, and then the point A is sliding as it is. That's what you are saying, Tulsi? Sorry, Tulasi? Is that your question is? Hello? Okay, so in that case it is the simple, so that about point B, that rod BC will rotate continuously, and these will slide up and down. So when, like, that is the standard, like the internal combustion engine, like that is how it's like operate, which you are saying, that it's just pinned at point B. It's a hinge joint at point B, okay, and you have this rod BC and CA, and the point A can slide, okay. So when that point A will slide vertically, like in the forward and return, this point B, or rather the rod BC, will make complete rotations about the point B. That is what it will happen. That is the typical IC engine problem. That is what that. So this is called crankshaft, this is called connecting rod, and this is called the cylinder. I think you learned all this, all of these if you are like engineering student. That is what, like in all engines, in bike and all these things, this is the mechanism, is like what you are saying. Okay, is this clear to you, that if you like do a roller or the pin or the hinge at point B, then the rod BC will rotate when this A will slide forward and backward. But we are not like that problem is little easy to do, I mean, as far as the calculation is concerned, but this is little tricky, so that's why we have given this problem. But the procedure which we will apply will be almost the same for both the things. That is what you need to remember. Okay, so I'll just go to the solution of this question. Yeah, so this is how you need to do it, using the concept of the relative velocity. Okay, so you have the VA and VV in that fashion. Now you take the rod AC and then draw the velocity diagrams, or the velocity. So A point has the velocity in upward direction, that is VA, and I am assuming that this rod AC has some angular velocity which is omega CA. That is what I am assuming. And if the rod, so the A point is moving vertically up, C point I don't know, but I am assuming that it has the angular velocity which is BC. So if this is the case, then the relative velocity of C with respect to A will be perpendicular to that rod, which is VCA. Okay, now the VCA, so this total angle is 30 plus 60 is 90 degrees, it is perpendicular. That is what I am assuming here. Okay, so that angle should be perpendicular, and this is 60 degrees given, I guess. Am I right? It is 60 degrees given. It is 400 millimeter, and that length has not given. So it should be 60 plus, yeah, it should be perpendicular. That means that angle should be 30. So that means this angle is 60. Yeah, and then that VCA is the omega CA into the distance r. Okay, and that is 0.4 meter. So if you now resolve this velocity VCA in vertical and the horizontal direction, so the vertically downward is the negative, and so this, like, we are using this convention. So this is the positive x, this is negative x, positive y, negative y. If you resolve this velocity into those two components, you will get the VC is equals to this, and here the only unknown is that omega CA. Similarly, for the rod BC, you can do the similar thing, that it has the velocity VB at point B, and point C has, if you as like assume a angular velocity of the rod BC as the omega CB, then it is again you can resolve this velocity into two components, like the horizontal and the vertical component, and you can write that what is the velocity of point C, and the velocity of point C in both the approach should be the same. So if you equate now the velocity of like the velocity you calculated using this relative velocity approach, where you assume that only I have assumed that what are the omega CA and omega CB, that is what is the unknown, okay, but the velocity overall of point C should be the same in both the way, that's the only constraint. Now if I compare these two velocities, okay, so that I component should be compared with I component, J component will be compared with the J component. So what is coming, if I compare I component with the I component, I am getting that omega CA is equals to omega CB. That means the angular velocity of both the rods are the same in this case, the magnitude wise, not the direction wise, that you need to understand, okay. Now again I will compare the jth component. Now if I do the jth component here, and I have already know that omega CA is equals to omega BC, if I do that, then I can calculate what is the omega CA or omega BC. It is this quantity. Then you put this quantity in any of these two expressions, probably in these expressions where omega CA or omega BC is the same. In any of these two expressions you will get what is the velocity of point C. So the velocity at point C is this quantity minus 1.44 I minus 0.5 J. This is the expressions for the velocity of point C. If you want to know the magnitude, it should be root of 0.5 square plus 1.44 square. So it is 1.528 meter per second. Okay, that is what you can easily calculate the velocity. So this is little tricky, but you need to understand it. Is that fine? Up to that, the rest 2 or 3 problems which I want to discuss is like again little tricky, but not that difficult. Is that clear to everyone? Clear, right? Okay, so let me move to the next question. So there is a very simple question, there is no complications involved here in this question. So you have a right angle bar rotate clockwise with an angular velocity which is decreasing at a rate of 4 radian per second square. The magnitude of acceleration of point A when omega, that means the rotation of that entire bar about the pinned point, is 2 radian per second. So what will you do, like what will be your approach in this case? And you have been asked that what is the magnitude of acceleration of point A. So the point A will have acceleration in both x and y direction, but if you think it in terms of the other way around, that means if you think it in terms of the normal tangent coordinates system, what will be the tangential acceleration of the point A, because ultimately the entire thing is rotating, right? So if you joint a line from this pinpoint to point A, that line is also rotating. So what is the acceleration of point A? The angular acceleration is given, I guess, that the right angle bar rotates clockwise with an angular velocity which is decreasing at a rate of this. So that means the angular acceleration is given, which is 4, the magnitude of which is 4 radian per second. So if this is the angular acceleration, then what is the angular velocity? Can someone tell me what is the, if this is the angular acceleration, then like what is the acceleration of the
Hypotenuse into angular acceleration.
Yeah, that's the case, right? So it should be, if angular acceleration is the alpha, and that distance between this point to O is root of 0.3 square plus 0.4 square, so that into alpha is the acceleration of point A, and that's the tangential acceleration, not the normal acceleration. That should be along those lines. Okay. Now what is the normal acceleration? That means the centrifugal acceleration. Centrifugal acceleration will be omega cross r. That is how you need to do it. So now you know the omega vector. Omega is 2k cap. So if it is rotating in this xy plane, that means the direction of omega should be perpendicular of that plane, and this is, if this is omega is equals to 2 radian per second, and this is clockwise. So if clockwise is positive, then and also at the same time it is given that angular acceleration, that is 4 radian per second, is decreasing. That means the alpha, if clockwise is positive, then the alpha should be also positive. Okay, so now we know that omega is equals to 2k cap, because it will be not in the x directions or the y direction, it will be in the z directions only, and in the z direction the unit vector is k cap. So 2k cap is my omega vector, and what is my r vector? Can someone tell me what from this figure what is my r vector?
Zero 0.4 I cap plus 0.3 K cap, J cap.
J cap, right? So you know r cap, you know r vector, you know omega vector. So what you need to do, omega cross r. So if you do that, it will give you what is the acceleration in the normal directions. So let me go to the solutions. Yeah, so this is a very simple tricks, that omega is equals to, if I assume that clockwise is negative, then it is minus 2k cap. Okay, and the angular velocity is positive 4k cap, because I have assumed that the clockwise is negative. So counterclockwise, so acceleration is decreasing, so that in a sense will be positive, but you can do the other way around also. It's just a matter of directions which is perpendicular to that xy plane, so it doesn't matter in that way. So RA, that means the position vector OA is equals to 0.4 I cap plus 0.3 J cap. You are absolutely right. So what is the angular velocity? So what is the acceleration in the normal direction? It is omega cross r. If you do that cross product, it will give us this minus 1.6 I minus 1.2 J. Okay, and the alpha t is the, and the AT, that means the acceleration along the tangential direction, is omega cross r. Is alpha cross r, where alpha is the angular acceleration. So if you do that, it is coming like this. So that total acceleration at point A should be the tangential acceleration plus normal acceleration. Acceleration along the tangential direction and the normal direction. So this is coming like this. And then the magnitude of this will be root of x component square plus y component square. It is 2.83 meter per second square. That's a very simple problem. I think you can do that easily. It just you have to just use the formula. Though I am not discussing that how you got that formula. I think you have already know, right, that how omega cross r is r you got. All of you know that. I think it is there in the book, as well as the instructor definitely taught it in the lecture. Now I will discuss the one last problem, which is again little tricky. All of you solve this problem. Problem number 7. Can any of you tell me that how how you can approach this problem? So again the trick is, here you need to use the concept of instantaneous center of zero velocity. That's the concept here for this problem. Now can any of you tell me that how will you approach this problem? So it is just two slider and they are connected by a rod, which is AB, whose length is given, and the slider A, okay, you need to calculate what is the velocity of the slider A, which is along the horizontal of the x direction, and when its distance from that origin XA is given as 0.85 L, where L is equals to 0.8 meter. So if this is the case, then okay, so you need to calculate what is the angular speed omega of the bar AB when that velocity is given, when V is given and L is given and XA is also given. So you need to ask what is the, you are asked that what is the angular velocity or angular speed of that rod AB. Anyone? Just any hints, how will you solve the problem? Here you need to know the instantaneous center of zero velocity. So I will tell you how you. So if you look at this figure carefully, okay, I think I'll solve it. So if you look at this figure carefully, if you draw a perpendicular line from point B along this, and if you draw a perpendicular line from point this along the vertical direction, so you draw a perpendicular line from here, okay, so what are the, no idea stuck in my mind, suggest me how to deal with this. I mean, you are talking about the problem 7 only, which I am discussing, or the previous one? Ashutosh? This problem only or the previous one? The problem 7, right? So let me go to the solution. If I show you the picture, it will be easy probably. Yeah, now look at this picture. So I draw a vertical line from B, it is like this, okay, along the slider, and I draw also a vertical line which is perpendicular to DA. So this point, when the two slots two sliders are uh, at this point I am calling it this point as D. I am denoting it. So I am drawing a perpendicular from point B to DB, which is this, and from point A to DA, which is this, and the intersection point of these two perpendicular lines is called, in this case, is the instantaneous center of zero velocity. That means now I can say that about point C my rod AB is rotating. So the whole point is that the point about which it's rotate, about that point the velocity is 0, right? The velocity at that point, let's something is rotating omega at about some point. So what is the velocity of that point? Is 0, right? I am saying that like you just assume a point and some length L, some bar, and it is rotating about that point. Okay, so what is the velocity of that rod at that point? It is 0, because that point is not rotating, it is rotating about that point, but in all other points of the rod it has some velocity, okay, when it will rotate. So that means, yeah, R into W, R into omega, exactly, that is what is the case. So when R is equals to 0, that means the velocity is 0, about which the point, like about what point it is rotating, the velocity of that point is 0. So in this case, this point C is that point about which the velocity is 0. That means the instantaneous center of zero velocity, point C. Now, so you need to read this concept in any textbook, in Merriam-Webster or something where it is there. You just read it very carefully from the book. But here I am just discussing it in the context of this problem. So that AB bar is rotating with angular velocity omega. I am just assuming that this bar has the angular velocity of omega about point C. That you need to now notice. Now it's again very simple geometry, nothing else. So this is my L. I have already assumed that this is alpha, beta and gamma, these three angles of this triangle ABC. Alpha, beta, gamma is there. Then I need to use the Lami's theorem, the sine formula. Okay, that means L by sine 60, this angle is 60 degree, which is given. L by sine 60 is equal to 0.5 L divided by sine dBA. Okay, so what is sine dBA? That means I am calculating this angle. So this angle will be equal to 47.4 degree, because I know that this is 60, this included angle is 60, okay, and I know XA is 0.85 L. So that angle is 60 and this total angle is 90 degree. So what is the alpha? 90 minus that angle dBA. What is then ABC? ABC is 90 minus that, which is alpha, is 42.6. I am just calculating all the angles now for that configuration, for this geometry. What is DAB? So DAB, I know this angle, which is 47.4, I know this is 60, so 180 minus the whole thing is 72.6. What is gamma finally? So that means the beta will be equal to 90 minus this angle, which is this. What is gamma? So I know alpha and beta. So gamma should be 180 minus of alpha plus beta, which is 120 degree approximately. Now I know all the three angles for this configuration, and I have given that this velocity is something 2 meter per second or something. This velocity is given. So then how will you do it? Again, you can say that sine gamma by L is equals to sine alpha by Ca. What is Ca? Ca is this distance. So you need to calculate Ca, and what is V? V is equals to omega into Ca. So it's rotating about that point C, right? It is rotating about that point C. If you know that length Ca, then omega into Ca will give me the V. So that is how I am interested to calculate what is the length Ca. So again, it is the Lami's theorem. I mean that sine formula. So Ca by sine alpha, Ca divided by sine alpha is L by sine gamma. That is what I am doing. Or the sine gamma by L is equals to that by that, the same thing. So from here I am calculating what is Ca. Ca is equals to 0.78 L, and L is given, by the way. So omega is equals to V by Ca, that is 3.2, approximately 3.2 radian per second. Any queries for this? I am not discuss any of the problems now. The rest is again in the same fashion and most probably easier than this. So you need to do it for your own. You have already submitted the assignment. So yeah, if you have any queries for this, please go ahead and ask. So that's so in the next problem also probably you need to use the concept of instantaneous center of zero velocity. So can someone tell me what is the instantaneous center of zero velocity for this problem number 8? Any of you? Just by seeing the figure, can someone tell me what is the instantaneous center of zero velocity?
It will be between A and C.
A and
A and C, between A and C.
it should be between A and C. Why you are saying it should be between A and C?
.4 is greater than 0.25, so it must intersect AC.
But it's the roller. Shouldn't it be point C exactly? Because if I draw the two, let me see.
No, sir.
It should be point C, right? That C should okay, because that roller is also rotating, right? I mean that roller is also translating. So it's not in that sense that is the instantaneous center of zero velocity. Yeah, you are right. It should be in between point A and point C. But if that roller doesn't rotate, I mean, if I am thinking of that thing, that if these are only sliding but this entire thing is not like this AB or this circle is not rotating, in that case the point C will be the instantaneous center of zero velocity, irrespective of how they are moving. But here in this case, when they will move, that roller will also move. Understood? Yeah. So in the second problem also, it's a very simple problem, I guess. So yeah, then you ask me if you have any other queries, any other concept. Otherwise, I'll stop it. So by the way, for the next week it is fine. The next week, I think Saturday will be a problem for me. Okay, that I will let you know. So okay, anyway, if you have any problem, please go ahead and ask. No problem, it's fine. So then okay, we will meet again next week, next Saturday. Fine.